Solve 2 times the natural log of x equals the natural log of 2 plus the natural log of 3x minus 4. Solution. So let's start by using some properties of logs so we can condense everything. So over here on the left, we have 2 times the natural log of x. Recall if you have a number, say p, times the natural log of x, what you can do with the p is you can bring it upstairs and write it as ln x to the p. This is called the power rule for logarithms. So we can write this as ln of x squared. This is equal to, over here we can use another formula. It says if you have the natural log of a plus the natural log of b, that's equal to the natural log of a times b. This one is called the product rule for logarithms. So here our a is 2 and our b is 3x minus 4. So this is the natural log of 2 times parentheses 3x minus 4. Okay, we're in a much better place now. So there's 2 ways to proceed. We can simply exponentiate both sides, or simply drop the logs, because whenever you have something like this, these must be the same. Let's go ahead and show some work. Recall that if you have e to the natural log of x, that's equal to x. This is a very, very powerful formula. So here we'll put an e, here we'll put an e. These go away, right? That's our x. So we have x squared equals, these go away. Let's go ahead and distribute. 2 times 3x is 6x. 2 times negative 4 is negative 8. Okay, now we have a quadratic equation. Whenever we have a quadratic equation and we're trying to solve it, as a general rule, you always want to set it equal to 0 and attempt to solve it. So we'll subtract 6x and add 8 to both sides. Just like that. Boom, boom. So we end up with x squared minus 6x plus 8, and that's equal to the number 0. Let's try to factor this. I'm pretty sure it will. So we can factor by guessing. So we'll write some parentheses like this, and we'll put an x here and an x here, because x times x is x squared. So now we need 2 numbers that multiply to 8 and add to negative 6. Well, 4 times 2 is equal to 8, and if they're both negative, they'll add to negative 6. So that should work. We set each piece equal to 0, and we can see that x is 4 or x is 2. But this is not the final solution. We need to check our answers because we have 2 logs. Also, when we brought up the 2 here at the beginning, we might have created an extra solution. So I'm going to go ahead and write down the original problem one more time. So 2 ln x equals natural log of 2 plus the natural log of 3x minus 4. And in order to check, we have to go back to this equation. It's really important to check when you have more than one log in an equation. So let's check 4. So if we check 4, we get 2 natural log of 4 equals natural log of 2 plus natural log. Let's see, 3 times 4 is 12. 12 minus 4 is 8. Okay, so we need to see if these are actually the same. Okay, we need to see if they're the same. So what we can do here is we can keep going. We can bring the 2 up. That's ln of 4 squared. And then here we can use the product rule for logs. 2 times 8, that's ln of 16. And that's correct. 4 squared is 16. Again, this is the product rule. I skipped a step here. It's ln 2 times 8, which is really ln of 16. So yeah, everything looks okay. So 4 is one of the answers. Let's check 2, see if 2 works. So checking 2, on the left-hand side, we'll have 2 ln 2. On the right-hand side, we have ln2 plus, putting a 2 here for the x is going to give us 3 times 2, which is 6. 6 minus 4 is 2. So we have the natural log of 2 plus the natural log of 2, which means we have 2 of them. And so, wow, that also checks. So in this example, both of them were actually solutions. Sometimes it doesn't check, and if it doesn't check, that means it's not a solution. But in this case, they actually both worked, which is sometimes kind of unusual. So it's kind of cool to see an example where they both worked.